Hi, I'm Neethu, Assistant Professor, Mechatronics Department, Nehru College of Engineering and Research Center, Pampadi. Today, I'm going to discuss about image compression. So, image compression is defined as the process of reducing the amount of data that is needed to represent a digital image. That is, image compression is nothing but we have to reduce the size of the image. As we all know, for the transmission as well as for receiving the data, the size of the image should be less. So, compressing in the sense, reducing the size of that image. Okay. So, this compression can be done by removing the redundant data. Redundant data is nothing but the data which is more than needed to represent an image. Okay, so after reducing the size of the image or after removing the redundant data, what happened? The image is compressed. Okay, then it is very easy for the storage or transmission of this compressed image. And while receiving, we can decompress this image by using suitable decompression techniques. Okay. Mainly, there are two types of digital image compression techniques. They are lossless compression as well as lossy compression. Lossless, another name for the lossless compression is error-free or information-preserving compression. And the second one is lossy compression. Okay, let us discuss about the applications of digital image processing or image compression. The first application is tele-video conferencing, the remote sensing, then document and medical imaging, fax, etc. We can discuss the application later, okay, right? Next comes the need for data compression. What is the need of compressing the image or the data? If data can be effectively compressed, wherever possible, the significant improvement in data throughput can be achieved. And if we are compressing the data or the file size up to 60 to 70%, what happened? The size, it is very easy to send from a transmitting section to a receiver section. Because if we are compressed in the sense, the size of the data is reduced. Okay. And the need of data compression is that it reduces the consumption of expensive resources such as hard disk space and transmission bandwidth, and it also reduces the memory space that is required and the cost of managing the data. Okay, if you are transmitting a data in the sense, if the size is too high, what happens? It will take more, or it will consume more the space in hard disk and also the transmission bandwidth. So, if we are reducing the data size in the sense, what happens? It is more compressed and it is very easy to transmit the data. Let us see some applications of data compression. One of the important application of data compression is satellite communication. As we all know, in satellite communication, large amount of data storage as well as transmission is involved. So, storing all these types of data without in a compressed manner and analyzing them without in a compressed manner is very difficult. So, if we are compressed the data in the sense, it is very easy to store as well as to transmit the data. And in the digital image processing, in the previous modules, we discussed about what is an image and what is digital image processing and all. In digital image processing techniques, usually have large volume of data. If you are transmitting an image in the sense, it contains a large amount of data. And storing of the image data needs large storage space and transmitting them needs wide channel capacity. These two requirements are reduced if you are compressing the data. That means in digital techniques or digital image processing techniques, we are handling with a large volume of data and storing as well as analyzing the data in such a manner that it is very difficult. So, if you are compressing in the sense, size will reduce and it is very easy for storing as well as for transmitting. In short, we can say that data compression is the process of reducing the amount of data that is needed to represent a given quantity of information. Okay, for a given quantity of information, we can reduce the amount of data that is used to represent that quantity. That is what we call as data compression. Okay, in the image compression or data compression, the one of the most important term is the data redundancy. Data, as we all know, something which carries information is what we call as data. Okay, for a given information, that is various types of representation are used for representing a data. In that representation, some of the representation are not relevant or which do not convey any information. And this representation is what we call as redundant data or data redundancy. So if this redundancy is removed, compression can be achieved. That means this type of information or this type of representation will not carry any useful information that are needed for representing an image. So if we are removing this redundant data, the compression is very easy. And the second term is relative data redundancy. In order to understand the relative data redundancy, let us consider the two data sets which represents the same information can be represented as N1 and N2, and the number of information carry bits in this data set. Now, the relative data redundancy is 1 minus 1 by CR, where CR is the compression ratio. Okay, this redundant data is removed in the sense what happens? It is very easy to represent the data in a compressed manner. Okay, next we can discuss about the various lossless compression techniques. Okay, lossless compression, another name for the lossless compression is error-free compression. Okay, lossless compression techniques, lossy compression techniques. This lossless compression techniques involves variable length coding, LZW coding, bit plane coding, lossless predictive coding. In this, variable length coding is used to reduce the coding redundancy, and as well as LZW coding, bit plane coding, lossless predictive